Our next speaker, Preston van Loon, is actually the co-founder and tech lead of Prysmatic Lab, which is one of the first teams that started looking at implementing ETH 2.0. And we all saw, like just yesterday, the ETH 2.0 yo. So it will be really exciting to hear about one of the ETH 2.0 veterans, if there is such a thing.
All right, thanks. I guess I have an underscore in my last name now, so that's cool. I want to talk to you guys today a little bit about what we're doing at Prysmatic Labs. Our focus is, of course, on Ethereum 2.0, but we like to say that we're targeting a production-ready client. So hopefully by the end of this, you'll understand what it means and how we're going to get there. This is Prysmatic Labs. We're a team of independent blockchain developers. Currently, there's 4 full-time people, 2 part-time people. But we also have 40 or so open source contributors. A lot of them come from the Gitcoin Bounties program, so that's super cool that we can engage the community and sort of get everybody involved in building Ethereum 2.0. Let's talk about why are we doing this and how are we going to do it. Well, it all started, I guess, at the end of 2017. Raul Jordan and I had seen this sharding FAQ, and we said, wow, you know, this is a really great idea. It seems pretty complete. It seems kind of stable, maybe. But we wanted to get involved, and what we'd understood was that Ethereum doesn't scale, especially at that time when we were seeing things like CryptoKitties and other applications sort of max out the blockchain already. On a global scale, the amount of users on Ethereum was relatively low, and the amount of capacity being used was extremely high. So we saw this as a really critical problem, and we wanted to get involved, and we wanted to start doing it. So we did. And today we have almost 2,000 commits. I think I took this snapshot on Tuesday. But we've been really trying to put this forth, to put this together, and just build it and help build Ethereum 2.0. So let's talk a little bit about the decisions we made on why we are building the client this way. So why use the Go programming language? Well, it has a lot of things that are just built in that are really helpful. So it has a mechanism for documenting your code in such a way that you already by default have a documentation page, and that's at godocs.org. Everybody who has a GitHub project has one. It's also type safe, so you don't really have to wonder what does this function take, what are the inputs here, and what are the outputs. You can be certain of what's going on. And when you're reviewing code without context, that's extremely helpful because you don't always have that background or the knowledge that the author had. If you can defer that from the code, that's excellent. It also has built-in garbage collection, so we don't really have to think about, of course we think about our memory allocation, but we don't have to think about returning it. It's just done for us, so that's great. And the standard library is amazing. You'll notice there are very few framework-like competitions for Go, at least compared to things like JavaScript, where there's like a framework for everything, like leftpad, where you're just padding, a number. So, also it's great for concurrency. So it seems to be a great candidate for us. Given that Ethereum 2.0 is an entirely new system and we're rewriting everything, we have this greenfield opportunity to sort of choose more robust tools. So what we've done here is we've taken some of these powerful technologies such as Bazel, which is a build tool, so that you can get really reproducible incremental builds. And what's great about it is it's language agnostic. So if we have some code in here that's Go or some Solidity or Java or whatever, we can build it all using the same command. Additionally, we have gRPC, which is a framework for client-server communication. Uses protocol buffers, which are really nice for having just performant and like type-safe and reliable wire protocol. Also using libp2p, that seems to be the best candidate for peer-to-peer communications, and then we're using BoltDB for our backend database. One thing that's we've come to learn over the last year is that the code quality is super important. We've actually already gone through several rewrites of the entire system, having to start over for one reason or another, and finding that we're going to be the maintainers of this code for a really long time. It needs to be excellent, because we're going to be looking at it for a long time. So this image on the right here is a snapshot from one of our team members' GitHub page, where you can sort of see what does their activity look like. Well, the majority of what everyone's doing is code review. We're usually reviewing more code than we're writing, and that way everybody's on the same page about what's going into the project. Is it the best idea, and is it excellent? Some of the things we enforce are that if you fix something, you need to have a test so that it doesn't get unfixed. A lot of times you might have a merge conflict and someone says, I'm not sure what this line is, I'll delete it. All the tests pass, it's probably not important. And you need to write the code so that you can understand it without having this additional context. And if you have new features, you need to have reasonable test coverage. It is not okay to just do one test to see that it doesn't panic or explode. It actually needs to go through all of the behaviors you can think of, especially any edge cases that might get you later. So some of the roadmaps so far, we started in January 2018 after Raul and I met in New York City to kind of get involved with Ethereum. And then in March of 2018, there was a ETH 2.0 workshop, I think the first of those kind. And since then, we've had several other major milestones. We merged, the research team merged Shardy and Casper. We came up with our proof of concept. This was a client that worked locally on your own machine without any network peering. We're really close to having our test network. The spec freeze is coming, that's great. And then we'll have these cross-client test networks. So the real question is, really, WinWin Testnet. This is the new WinWin Testnet. So we actually had one for over a month now. It just doesn't last very long. So when we're talking about testnets, we have two types. We have short-lived types that can span from just a few days or weeks or months, and then we have long-lived test networks that we expect to run until all of eternity or until they stop being useful. These ones are so short-lived that you'll come back an hour later and it's dead. So it's not very useful yet. But we're getting really close. Every day it goes a little bit farther. If we learn something new, we find a new bug. It's getting super close. So how do we orchestrate this? Naturally, this blockchain system is a network of machines. So one idea is that we could just take 4 computers here that are on the same network and connect all them together. This doesn't scale very well because you need to buy new machines or you need to spin up new virtual servers or whatever. So we've taken to a framework called Kubernetes and sort of used this tool to manage our orchestration of our containers here. So there's a lot going on in this picture, but basically we can, any of these processes, if we wanted to scale them out, so if we wanted more beacon nodes, we could just change the number from 50 to 100, and then they will get scheduled, and as long as we have enough resources available. And likewise with the validators, we can easily scale them up and sort of see new validators come in and out and really architect our test network in sort of a one-click deployment. So what do you need for the test network? Well, you need some kind of scalable infrastructure, like we just saw. You need some sort of reliable ETH 1.0 test network. So we're using the Goerli network because we want this to be real deposits coming from a real Ethereum-like chain. We want to make sure that it works locally, of course, so we're not wasting our time. We want it to be accessible to outside peers so we can connect to it. It's not just a simulation. And you want to make sure you don't have any plans for a few hours because you're going to be just staring at it, watching it as soon as you launch it. So we check all of our boxes. We're ready to go. Let's do it. Let's deploy this test network. So we do it, we slap this big blue button, and then we say, all right, wow, the logs are flowing. Look at all these colors. I'm just in euphoria right now. This is amazing. But this is just one of the validators, and there were 16,000. So how do I understand what's really going on in my system? Well, we have metrics instrumentation, and we can build dashboards like this. So what we see here is we have a very nice up and to the right, which is the blockchain height over time. We really want to see that be going up really nicely. We're getting finalization, justification. We're seeing new validators come in and get deposited. Their deposits are included in blocks. This is all looking really great. We have some healthy network traffic. Things are looking good. But then sometimes things don't look so good. So all of these charts look super scary, and it's kind of hard to see this kind of information just from logs alone. So we find this is a really, really powerful tool. But if we find ourselves in this scenario, we say, oh, wow, something is just churning through resources. We have 250,000 subroutines running concurrently. So what is going on? How can we even like further dive into some of the things wrong with the system? So we actually have this idea called request tracing, and we're using a framework called OpenCensus to achieve this. And here we can see the life cycle of a request from start to finish. So we can see when a validator proposes a block, well, how long does every step of that take, including propagation through our network. So that can be really nice for finding issues. We can see that this block took almost 300 milliseconds to propose. Sometimes we have errors. So we'll want to query for, okay, what was an error? When did it happen? Sort of on what method and why? That can be super helpful. And then sort of the next steps, like after we have all this stuff together, we have a running test network, we can really understand what's going on. Well, we don't want to break it. So we're going to be enforcing a lot of rules. So we already have enforced unit tests on pre-submit. And this is going to include the E2.0 conformance testing. So we'll be conformant with what the specification requires, and we'll be in line with other clients. But we'll also have more full-fledged end-to-end testing. So you can imagine standing up 2 or 3 beacon nodes on your own machine and then running them with messages passing back and forth, and things are getting validated and finalized and whatnot. And that can be part of the unit test suite that's required on pre-submit, or at least required before a new release can be tagged. And then going one step further is we want to actually launch potentially launch a mini cluster like we saw before, with some non-trivial amount of validators, and just see that even in larger conditions, it still works. And then following that, we'll have things like canary deployments. So deploying a new version out to the test network, and then maybe routing like 5% of the traffic to it to see that it's not knocking things over, that validators are not getting slashed, so we can monitor this and then gradually roll out everything. So just to recap, like, what does it mean to us to be production ready? We need to hold yourself to really high standards, because you are the maintainer of your code. Your team's the maintainer. If you don't do it, you're just going to be upset with yourself in the future, because you're going to say, what is this? Who did this? And when you look at the blame, it's actually you. So it's just better to hold yourself to these high standards. You need to be able to understand your system somehow. Just using log ingestion alone is sometimes not enough. It's still super helpful, but you sort of need some high-level picture of what is going on with your code, and you need to be able to dive into it deeper. And this is useful for identifying those regressions from new deployments, or just identifying bottlenecks, things you need to fix. Some examples, so you might have these failure rates, and you're understanding, oh, why did this take too long, or what's taking too long, and also areas for redundant work. You might see that in one request, you're fetching the same information from the database 100 times when you could have been caching that data because it's not actually changing. And the most important thing to take away here is once you get it running, don't break the build. Once we get this test network running, our goal is not to knock it over. It's to advance it, to make it faster, to make it a little bit more performant, and to keep it going. And that's it for me. Thanks, everybody.